to have measurable success of criteria. So once you have that, you need to have DevOps as well, because if you build with the business, the ops, the operation also need to talk with the business and to deploy faster so that you can release more features and get them live as soon as possible. And so we have a standard for DevOps, which is very clear, is that on a project we need to be in production from week 2, because we do sprints of 1 week. And so when we started doing mobile, we realized it was much harder to have this standard met for various reasons that I'll go through. So this is a constraint that we have, be in production from week 2. And then there's lean startup, which is that once it's in production, we need to actually learn from the customers that are using the apps, and we need to iterate on that to basically build a better product. And for that, the standard that we have is that we need to have weekly customer feedback, and that means that we don't only need to deploy the app in production on a weekly basis, we also need it to be live to get actual customer feedback on it. So there are constraints with that. So we were doing pretty good with web development because we have teams of experts in PHP, JavaScript that are quite amazing, and they build apps fast. So that was a bit our utopia when we were doing just web. For the web, and we're not seeing really well what's happening, but it's the Chrome Dev tool. We have great tools for developing apps. We can just inspect the DOM of the HTML that you have on the page. You can make changes live. You have network tabs to inspect what's going on in your app, what are the routes that are being called. So you have a lot of great development tools that allow you to debug and to build faster your apps and to build them faster. We also have great build tools for that. Back then we were using Gulp. Gulp was great at basically generating the assets, notification, having a server which live reloads, so you can work faster and don't have to compile stuff, which can be cumbersome. We moved on to, as I think many of the web devs, to Webpack, which has been a great improvement, works great with React. And basically it allows you to put everything in a JavaScript bundle. It can be HTML, JavaScript, CSS, Jade, whatever, you name it, there's a loader for it, and you can just put it in your app. So it's clear that we have a great way of building your web apps. And finally, for the deployment process, which is more for DevOps, the process that we usually have is that when we start a project, we grab an Amazon EC2 instance, which is fresh and clean. And then we use a generator to create an Ansible provisioning for that, so that we can prepare the machine to get everything running on it. So this is a bit what we have here. Once we generate the Ansible provisioning will install, can be PHP, can be Node.js, depending on the project, but it gets everything in the EC2 instance. And then we have our web app, and the only thing left to do is to deploy it with ship it. And what's amazing is that you can do continuous deployment with CI services like Circle CI and stuff. But what's the most amazing, I think, is for web apps, I think that's what's very exciting about it, is that once you deploy the version of your app, all your customers get it. So we're really solving the problem of deploying equals getting customer feedback. They're forced to get your latest updates, and that allows you to be agile. And this is something that we don't have as easily, at least for mobile. I'm trying to give answers on how we can reach the same level of agility. So yeah, we had everything ready. We had a generator for Ansible. We have a generator for the deployment pipeline. We can put that on Circle CI. So if the web is so great, the initial approach is, okay, let's try to just put the web in a mobile app. So this is our initial thought. This is something that we started maybe 2 years ago when we started taking actual mobile projects. We felt we were mature enough to take those. And so for that, the major approach is the web view approach, which has been started by PhoneGap and Page Cordova. And so basically the idea is that you have a web view, which is simply some sort of a browser, where you can put HTML, JavaScript, CSS to get an app inside the web view. And then Cordova just bundles that in a mobile app. And it was really helpful because it allowed us to have web projects that were lasting for 6 months or more, and in 2 weeks we had a more or less functioning app, I guess, some little glitches apart. But it allowed us to actually get an MVP for a mobile app quite quickly, and it was quite cool. To go a bit even further, the major player that's been using that route is Ionic, which is combining Cordova with AngularJS. We were relying back then a lot on AngularJS as well, so it made sense for us to try out Ionic. Basically what Ionic does, it provides a wrapper around Cordova, so you can emulate, you can build, you can have a web server to make your changes, and then you can deploy it on an actual device. And it also provides basically all the features of Angular, you can use them, plus some extra stuff that are must-haves in mobile apps, such as a side menu or tabs or a navigation stack. All these stuff that are going to be quite likely in your mobile projects, well, Ionic gave it to you. So it was an initial good approach. The issues that we had were three main issues that we have were the performance issues. Because when you use a web view, you have devices, especially low-end Android device, which can take a lot of time to load. And when you have screen transitions, especially those which involve calling the network or doing some heavy processing, you can sense that it's not behaving like a real native app. So that's the first problem that we had. And a problem that is also, I think, inherent with AngularJS. When you start building a large app, you need to be super good at Angular to keep it running on low-end devices, because it was made for single-page apps initially. The second aspect of things is that writing reusable code is hard with Angular 1. They've made some improvements by introducing components and moving to Angular 2 and Ionic 2, which I haven't tried, by the way. If some of you guys want to discuss it, I'd be happy to. So they made some improvement, but back then when we were using Ionic, it was not easy to actually reuse components. We had directives, but it was very hard to know that a directive could be reused in your app. It was quite complex. The last issue, I think, is the look and feel of the app. Basically, people could tell that it was not a native app. I'm not sure why, actually, because you could do whatever you want with CSS, but you could actually sense that it was not a native app, and so the clients felt that the quality was not there for their apps when we built them with Ionic. So we had to find alternative solutions to that. So the current stack that we use now, and which I'm going to present, is using React Native, Fastlane, and Code Push. So this is the basic stack that allowed us to solve our different problems that I mentioned before. So the React Native approach is quite simple. The idea, well, actually it's quite complex, I think. Just the basics of them are simple, but I'm thinking the guys at Facebook have done some tricky stuff. But the idea is that you have some React native code, including the React library and all sort of vendors that you might include in your app, which you can find online on npm.js or JS Coach. It's a great resource to find modules. And so React Native, when you run the app, it launches a little terminal console here, and it bundles your whole app inside a bundle. And once that bundle is ready, when you run it on your mobile app, it's going to create some native components on the fly. So this is the main difference. It's not a web view that is running some web code. It's actually rendering dynamically native components. So you have native components for iOS, and you have different native components for Android. And React Native does the magic by doing the mapping and creating them on the fly. So the main impact of this is that you have a much better performance, of course, because it's using what Apple or Android would recommend under the hood to build performant apps. And the other impact is for the UX as well, because you can get quite easily a native UX for your React Native apps. So this is, when it started, it was difficult to use it in production because a lot of the Android mappings were not done yet, but now it's become really mature, so we've decided to really bet on the React Native approach, especially since we're using React for the web as well. So now that we've made our choice, our main goal is to go fast, and to go fast both for coding, for deploying, and everything that's involved in the coding process to produce quality products in little time. So I think the main aspect of speed would be reusability, and this is something that React is super good at because it's building components that you can reuse. So React in itself is a good choice for that, and React Native is a good choice as well because even though you don't necessarily have to write the same code for iOS and Android, you actually can, and most often this will work out fine. Obviously you have to take care of some differences in the UX, but if you want to just do a short MVP of 5-6 weeks, you can have an app that works both on iOS and Android with a lot of code reuse. I'm going to show some examples of that. So the goal that we have is, this is like the utopia as well, we haven't reached that, but it's to spend zero time rewriting code. And when we actually write extra code, it's on purpose to have some difference on Android and iOS, which you can want. Some example might be the tab bar that is supposed to be on top on Android and on the bottom of the screen on iOS. The way the menu on top looks is also different. The text is left aligned on Android, it's not the case on iOS. So if you spend some time rewriting code, you want it to add value, and so we don't want to rewrite anything that would be useless. So React component, it's going to be very, very basic for those who already know it, but basically it's quite simple. Let me see, actually, yeah, that's okay. So a React component is using inside other components, children, as you can see. In that case, it's a simple button component, which includes the touchable opacity element, which is a React Native element, which allows you to basically have a function be called when you press on it, and to have a nice little lightning effect when you touch it. And so in that component, it's very simple. You have the touchable opacity, which handles the press event. Inside, you have a view, which you can style however you want, using Flex, which is quite nice. And inside, a text where you can put whatever you want. And as you can see, you have two properties that you can give to a button. The text that is required, and which will appear in the button, otherwise there wouldn't be any button. And the onPress handler is going to be called when you actually touch the button. And so once you've done that, you actually can reuse that button wherever you want in your app. It's very short, I don't know how many lines that is, but it's quite practical. So now, what if you want to have a small difference in styling between your iOS and your Android app? So I'm talking about a small style change. In that case, I took the example of putting the border radius on buttons, but only on Android for some reason, because you don't want to have those on iOS. So you have React Native provides you with the platform.os method, which returns either iOS or Android. And so you can just create your variable and use that. For instance, I put it in the view in that case so that the button shows around the edge on Android and not on iOS. So it's quite easy to have some small tweaks of style or some additional, some very small changes. It's quite nice. And then if you want to go a bit further, if you have big differences between components, you can actually just create one file which would be called button.ios.js. And one file that is called button.android.js, and React Native, when you actually use the button, will pick up whichever fits the platform of the user. So in that case, for instance, I decided on Android to add before the text a button text, and also to use a different touchable component, because React Native provides you with quite an extensive list of components. For instance, on Android, in that case, I want to have the highlight effect when I touch a button. But for some reason on iOS, I want to have a change of opacity of the button when you click on it. So you can basically, in that case, this approach works well because the button is quite different in terms of structure. It doesn't use the same parent component, so it's a quick example. And how to use now a React component is quite simple. You just create the component, you provide it with the text that you want. And in that case, the onPress handler is going to redirect the user to the home page of the screen. And so when you do that, it's actually going to use, as I said, the iOS version on iOS and the Android version on Android. So overall, reusability has improved a lot. Facebook, when they first tried out the Facebook App Manager, which was the first app built on React Native, they were able to reuse 85% of the code, which is quite nice, and they had a lot of differences in the two versions also, so I think they reached a very high level of reusability. On the last project I did, which was an 8 weeks project, I was able to write 0 lines of native code, actually, so I didn't have to know Objective-C, Swift, or Java. I do remember a bit of Objective-C, but it's far away, so I'm glad I didn't have to touch that. I used 8 times platform.os, and there was only 2 components where I had to build a different version. As I mentioned, it's the tab bar. So obviously I could have done a lot more if we had more time, but in that case the idea was to get an MVP out there that was looking okay for both iOS and Android. So I think the purpose is that you can be really focusing on reusability if you want to. So now productivity, I'm gonna do a short live demo of what you can do. The idea is to get as close as possible as the experience you had on web applications, which is live reloading, inspecting the DOM and stuff like that. And React Native does that quite nicely. So basically here I have a simulator running with so the screen is quite small, so I have issues with resolution. I'll see what I can do. Okay. Something. Okay, so I have my project running. I can just use the simulator to reload. As you can see, what it's saying is that it's reloading from a local host 8081, and this is where the actual bundle.js is being generated by React Native. Once I launch the simulator, it bundles that in a JS file, and that's what React Native simulator is hooked up to. And so I have some cool options, development options, including the inspector, which does a bit the same as what you could do on Chrome. I can inspect all the views that I have on my screen. I can see the padding, the margin, all this stuff. So it's quite practical. I have some information about performance as well that don't seem to work because nothing's going on in my screen, I think. And an error, great. So let's say I want to enable what's called hot reloading, so it's actually already enabled. And this allows you to basically have your changes be applied directly in the simulator without needing to recompile, which was a big pain for those of you who've done some Xcode manipulation, stuff like that. So let's say I want to quickly change a text. So I'll remove button once again. And if I save, it's doing the hot loading and it's directly updating on the simulator. So it's really good because I don't have to recompile, I don't have to even reload, it's directly synced. I can develop much faster using that. You also have if you want to go a bit further, you also have an actual hook to the Chrome debugger, which you can run, and I don't know where it has opened, probably on another window, yeah. And here I can just actually have a console where everything, the console logs that I have put in my code are going to appear. The network doesn't work currently, so maybe they'll put that in. And the reason is that basically the network calls are not done by JavaScript, they're made by the native code, so the Chrome debugger can't pick that up. But you have the console, which is what's useful for that. So there's a quick demo of what you can do. You just run it once, and then you can use it without having to reload it. And I don't know where my stuff is now. I think it's actually this one. Okay. So productivity is checked as well. What about now deployment? And deployment was, I think, the biggest challenge to overcome for mobile apps. Why is it a challenge? Because, for instance, Apple applications can take 2 weeks for Apple to review changes. So when you deploy on the App Store, you potentially need to wait 2 weeks, and that means that our standard of deploying from week 2 and on a weekly basis cannot be met as it currently is. So the first step for us was to automate the deployment. The goal is to deploy fast, basically. So what's the native situation of deployment? So Android is quite simple. You build the app using Gradle, which is a Java tool. And then you sign it using what's called the key store so that it can be released on the App Store, because initially the apps are unsigned and the signing does that. And iOS is probably as simple, not really. It's a nightmare. If you've ever done it, I think all people who have ever done it always remember the first time they've done it, because it usually takes days to get it right. You need a signing certificate, you need to create an app ID for your app, potentially you need to set up the push notification certificate as well. You need to set some entitlements if you might want to use background mode, hook it to the game center. There's a great interface which only works good on Safari for that, it's called Developer Apple. You create a provisioning profile, then you feed all this stuff to Xcode, which does some magic that sometimes destroys all the work you've done. And then you hope it works. So yeah, it's not something that we wanted to do. Our motto is when you have to be somewhere else than a terminal, there's probably something you can automate. So we didn't want to open Xcode at all. So the answer to that for us has been Fastlane. And Fastlane provides you with a lot of automation tools for your mobile apps. Some are quite secondary, such as generating the screen captures that you may want to submit on the App Store, because I know that Apple used to require at least 5 screens for every language, for every size of screen, which was nice every time you wanted to deploy. So Fastlane has something to do that. But basically for the deployment pipeline, what we're using is 3 modules of Fastlane. The first is Match, which removes all these steps before the signing of the app. I'm gonna go in detail on what it does. Then there's Gym that actually automates what Xcode is doing when it's building the app. And then there's Deliver, which takes what's been built and push it on the App Store. So you only have to care about identity description and stuff like that. So here's a sample Fastlane configuration that you might have on your project. This is the one that we had on the latest project. So as you can see, you have some tasks that you can run. This is a lane that we call deploy that is applied for iOS. And what it does is that, first of all, it's going to run a small SH script. I left it there to show you that if you want to do something custom, you can do that with Fastlane. You can just write a bash script and it's going to run in your deployment pipeline. And then it's running Match, it's running Gym, and if it's, because we have several environments, if it's the staging app on which the client validates our features on a daily basis, it's going to deploy it to Hockey app, which is some sort of private store, which doesn't rely on the App Store and the long process it takes for Apple to process the build and to review it. And if it's a production app, it's going to use Deliver to push it to the App Store. So it's very, very short. I can just pass an environment when I launch my deploy command. It's going to pick it up and it's going to inject all the environment variables that Fastlane needs to hook up to either our in-house Apple account or the clients. So it does that with just these lines. To go a bit more in detail in Match, which was, to me, is the most amazing part of Fastlane today. The problem that we were having is that all these files, the signing certificate and the provisioning profile, had to be shared within the team. And it was very difficult to find an effective way to onboard new developers. And what Match does is that it just automates the stuff that you had to do on Apple Developer. It picks up, it creates if it doesn't exist, otherwise it picks up what's on Apple Developer, the signing certificate and the provisioning profile. It encrypts those and it pushes them to a private Git repository, which you own. And when someone new joins the team, he can just run this Fastlane, and it will, if he provides the good passphrase for the Git repo, it will pick up all the info that are stored on the Git repository, the signing certificate, the provisioning profile, which means that without me needing to give him any file, he's going to be able to deploy in 5 minutes. So it's a great achievement, and Match allows you to simplify that part, which was the hardest to me when deploying that. So this is a bit our current process for building an app when we do a mobile app. So we have our React Native app, and it's hooked up to 3 different stores. Hockey app is the part that is for the staging application on which the client validates on a daily basis. It usually hits a staging backend, so a different backend that we have, usually Node.js or Python, it depends on the case, with its own database. And then there's the production environment, which uses 2 different stores, the Google Play Store for Android users and the App Store for iOS users. And those apps will hit the production backend, which is on the top right. And so the React Native app, thanks to Fastlane, I can just hook up these different deploys. For staging, it's going to grab our Theodo in-house development distribution certificate and provisioning profiles, which allows me to push to Hockey app, because an app store wouldn't allow me to do that. So once it's done that, it pushes on Hockey app, the client can download and try the feature. We can deploy usually 3 or 4 times a day, which is something we wouldn't be able to do with the app store. For iOS, it does the same, but with the client's signing certificate and provisioning profile. Pushes to the app store. Sometimes the client wants to do some beta testing with test flights, so that's something that we might add in between, but not in all cases. And for Android, it's actually, Fastlane provides also lanes for Android, but it's quite simpler because it's just doing what I said before. It's building using Gradle, and then it's signing the app and pushing that to Hockey app. So we're using usually the same key store for staging and environment. We secure it, but we use that. So this is our production pipeline that we use to deploy Theodo. So if you want to get this at home, we've actually built a generator for that, which is going to generate the whole fastend configuration that I mentioned, this lane that allows you to deploy directly on iOS and Android on a Hotkey app. It also provides the support for multiple environments out of the box, so you have one command that generates the setup of the fastend configuration, and you have one command to generate a new environment. So if you have staging, pre-prod, or want to do A/B testing or whatever, that's something that you can actually do with the generator. It also includes other stuff to generate icons, bash prints. You can check it out. This is what we use to add in most of our initial features that we want to have in the React Native app, including linting and stuff like that, and testing. So testing. So because I actually didn't plan to talk about this, but at speaker's dinner, I was told that I had to talk about it, so I will talk about it. And the reason I was reluctant is that I didn't see initially the link with speed, but actually when you do proper testing, you have quality products, and then you don't have rework to do, so actually this increases the speed. So what kind of tests do we do to have quality apps where you don't have to do rework? So obviously we have unit tests, which are mostly used in React Native apps to handle the state management of your app. So it's a very simple unit test. You check that when a certain action changes the state of your app, the state looks like it should be. And then you need to actually test the components that you have in your app. And for that, we have the first level of testing is shallow rendering testing. The idea is that you create a wrapper around a component. In that case, it's an app bar. And it's just going to see the first level of children of that component. It's not even going to go all the way to the bottom of the tree. So you won't be able to see exactly how your tree looks like, but you're going to be able to see at what level, and one level. And in that case, for instance, we're just checking that this navbar component does have a touchable opacity element that is clickable. And then we can actually simulate a press on that component and check that the function that was supposed to be called when the guy clicked on the right icon of the navbar is called. So in that case, we check that the user is going to be basically taken to the profile of the user ID number 2. So you can simulate simple actions. It doesn't do the whole range of end-to-end testing, which I'm going to get to, but it does allow you to test a lot of stuff. So speaking about end-to-end testing, I think most of you have lived that basically when you get started and you have either your web browser or the simulator showing up. It's a bit of a honeymoon phase because you're super excited, you see stuff moving on its own, you start writing a lot of tests, you think it's great. And then very quickly, actually I think around 1 month or 2 in, you get to the morning phase. So it has several phases in it. First is denial. This is when you see that little test that sometimes fails, but not always, like once every 4 times. Then you get angry because it happens more and more frequently. So you start getting new computers. There's bargaining when you ask your client to spend time on actually finding long-term solutions to fix that problem. Then there's depression when you actually ignore that the tests are red because you think that it's anyway random and it doesn't matter. And then there's acceptance when you actually remove the end-to-end testing of your project. So I'm not sure many of you have lived this, but I have. So if you still want to give it a shot, I would not recommend that because I haven't found a good solution for that. There are several solutions. Calabash Cucumber allows you to have acceptance testing, so you define your steps and it's going to run them in the simulator. It works for iOS and Android. You have Apium as well, which does the same. And there's something that got out maybe 1 or 2 months ago, which is called Detox. I wasn't able to set it up, so I think it's quite early yet. But this should allow you to get some end-to-end testing ready in your app. Try to keep it minimal so that you don't go through the same scars as I have. There's an alternative, however, which is snapshot testing. So the idea is quite innovative. It's the only kind of test that could catch if you were to add, for instance, a picture of a bear in your app. So end-to-end testing wouldn't be able to detect that. You wouldn't have a test that says there's no bear on that page. You wouldn't have that. And snapshot testing is going to allow you to do that. Basically, the idea is that you provide the component which you want to snapshot. Usually what I do is that I snapshot the whole screens of the app, so that I include the whole DOM of my application. Given a certain state, for instance here it's the login screen when my state includes the email and the password. It's going to basically render a form where the email and the password fields are filled. And the renderer is going to map that to a JSON file And we just expect our component to match the snapshot that was previously generated. The idea is that when you run it, if you've made a change somewhere in the tree of this scene, either it's on purpose because it's the feature, so you'll see the snapshot has actually changed. Do you want that? If you say yes, then it's going to update it. Or it's actually a regression. And for instance, a picture of the bear that you didn't want might show up, and it's going to show you the image of the bear, and you're going to say, no, I don't want that because it wasn't the feature at all. So maybe I can try to give you a short demo of that. So to run the test, it uses Jest, because it's Jest snapshot testing. So for instance, in that app, I had I set it up really quickly on this one. I had 2 snapshot tests. If we look a bit at what's inside, it's generating snap files for the login screen, for instance. And this is actually a whole tree, the whole tree of the login screen. So it includes everything, the style included, everything is out there. And if I was, for instance, to change the background color of a tab, which is included in one of my screens. So let's say I want to make it black. I'll save that. If I run the test, it's going to show me very explicitly what has changed in my components. So it's going to say that the test failed. So let's say that actually this was my feature. I need to change the color of the tabs. I can just put -u, and this is going to update the snapshot. So the idea is to commit as well on Git the snapshot that you have, so that code review can also see, oh, you changed the snapshot, is that on purpose, or were you just too lazy to check out what the snapshot test told you? So now it's passing because I've updated the snapshot. So it's quite easy to set up. It doesn't allow you to quite catch what an end-to-end test would, but if you combine in a smart way shallow testing where you can simulate presses and snapshot testing, you can get something that runs quickly, way quicker than end-to-end testing, and that is not flaky at all, and it's not going to fail on you for no reason. So it's an interesting approach to try out. Now let's come back to deployment, because we still haven't fixed one issue, which is quite big, which is the issue to deploy weekly in production. Because right now we know how to deploy fast using Fastlane, but Apple still needs to validate the changes we made on the app, and it can take up to 2 weeks. So we wouldn't be able to meet our standard that we have at Hero. So how can we go even faster? Well, we are going to have to mess with Apple on this one. Apple allows you to do some updating of the assets of the app. So you could technically update some CSS and JavaScript. What is great is that in our case, assets are the actual code of the app. So you can change it as long as you don't totally switch the behavior of the app. Apple is going to actually allow you to update without needing their approval. And this is something that Ionic used to do with, and still does actually, with Ionic Deploy. And now I think the main player that does this is CodePush from Microsoft. What's the idea behind it? The idea is that we still have our React code and vendors that is bundled into a JS file. The difference is that it's pushed to the web. And when you start your React Native app, if it has an update available, it's going to fetch that from the web and to update the app. So technically, the user doesn't even have to agree to updating. You can just have technically the same stuff as on the web. You update and everyone sees it, which is really, really practical. You have several strategies for that. You could show a pop-in if you want to say an update is available, would you like to restart now? You could just restart it forcefully if you want, even though it might be a problem if the user was doing something in the app. Because when the user sees the changes, they actually need to have the app reloaded to see those. So CodePush provides you ways to bypass the Apple validation. It also has some cool stuff to handle multi-environment deployments. For instance, you want to push some changes but only to the staging environment, that's something you can do, and then when it's validated, you can push it to production as well. You can do some progressive rollouts. If you want to say, I want 20% of my users to get this change so that I can A/B test, is it a good improvement or not, that's something you can do as well. And the main problem that you have is that it can't do native changes, because if you change some Objective-C Java code, this is not an asset, this is not JavaScript files, and Apple, CodePush won't be able to update that. So, to give a very specific examples, if suddenly you want to add push notifications to your app, this requires changes on both the provisioning of the app and the native code, so code push is not going to be able to do that. So the solution that we're using at Theodo for that is it's some sort of a flow of deployment. Let's say that we have our initial release that is done on the store, which is 1.0.0. If I bring a new feature, that doesn't require binary changes. I can just name it 1.1.0 and deploy it using code push. I have a small bug fix to make, so it's going to be 1.1.1. Again, I can push it using code push. And then suddenly I have a binary change because I need to have push notifications in my app. So what we can do then is to actually trigger a new deploy using Fastlane, which is going to be pushed on the stores. So I have the version 2.0.0. I can start iterating on the new version that has been released, so 2.1.0. And if I find a huge bug that is also in the previous version, I could just cherry pick that bug, and code push could release it both for the version 1 and for the version 2 of the app, so that the users that didn't already yet update using the App Store, using the official method, are still going to get that bug fixed. So it requires some rigor on the way you name branches, and it's a bit cumbersome to actually cherry pick comments so that you can deploy them on older versions. So you need to have a really clean way of tracking tags and releases on GitHub to do that correctly. But technically, you should be able to minimize the number of times you have to do some binary changes. If you can group them, it's usually a good idea. If you know, for instance, that in 2 weeks you're going to have not only push notifications but also background location checks, you can just modify the native code at that time so that code push will be able to do the update later. Try to minimize those binary changes, basically. So to look a bit at the different things we've seen, so we need to match 3 main things. The first one was more for Scrum. It was to have client satisfaction through speed. React Native allows us to do that by writing code once and being able to deploy most of it on those platforms. We wanted to have a weekly deploy in production, and so Fastlane was great for that because I was able to automate the pipeline, put it on Circle CI even to increase the speed at which it's deploying. And finally, getting customer feedback was a constraint that was met by code push because it allows me to actually force users to get my latest update and not hope that they will sometime download it from the App Store if Apple ever validates it. So overall, I think we're not quite there yet because the binary changes, as I've said, do still require the Apple validation. So in some cases, we actually have to fail that standard when we have to release very fast a binary update. But in most cases, we were able to succeed in all our projects now, and hopefully we can talk about you guys' pipeline if you have one as well. And that's it for me, if you have questions.
Regarding the things you said about the iOS, from what I know, they decreased the validation time from only for the initial submit it's 2 weeks, and after that it's 3-4 days.
Yeah, exactly. To be honest, they've made some progress on it. Most of the times they manage to do it even within 2 days or stuff. But
Why don't you use Testify for testing your app?
Because you mean for having the client validate features?
Could you repeat this question?
Yeah, okay. So the question you had was why don't we use TestFlight to have our client validate the daily features that we do? And the reason is that we do user stories in Scrum that last less than a day. So very often we have to deploy features 2 or 3 times a day. And TestFlight requires some processing time when you deploy builds, which we don't have with Hockey apps. So to gain some agility and to go faster, we chose to use a private store for that.
I know it uses 1 or 2 hours.
It was a quick improvement to make, so we decided to go that route. But it's something that can be done as well using TestFlight for sure.
The ones that did not do any mobile development or even do React Native, could you give some examples of what's considered to be changes to the binary part and what can be updated from the behavior of the app directly through code push?
So basically, when you add a library to your app, yes, the question, sorry. So what you ask is basically how can we know if a changes needs to be binary or not and require this process? So basically, when you install a new library for your React Native app, there are two types of libraries. Some of them are pure JavaScript, and in that case, you know that you're going to be able to use code push. And some of them in the README, you'll see that it says installation and then linking step. And linking means that it's actually going to add some native frameworks and some native changes, basically. So when you have to use these kind of libraries, then you know it has to be a binary change. And very often, this is the case when it requires some extra components that don't exist in the core of React Native. If it's, for instance, a slider, it can be done using just simple views that you style and stuff like that. But sometimes when it's something that has to do with, let's say, clicking on a button that opens the email, the native email browser of your phone, then it's very likely to be a binary change to which you won't be able to deploy using code push. And for Cordova, which was the Ionic approach, if some of you guys are interested, every time you had to add a Cordova plugin, that, for instance, accessing emails or accessing the camera, for instance, this was also a binary change and you had to go through the long process. So yeah, try to predict your sprints ahead of time to know what you're expected to get in your app in the coming weeks and try to group those changes as much as possible to avoid having to do that often.
Does the emulator that you showed us eliminate the look and feel from iPhone and iOS system? Because when you develop with Ionic, you use the Chrome emulator, and does the Chrome emulator doesn't all the time emulate exactly the look and feel from iPhone and iOS.
But this is the big difference between Ionic and React Native is that the question again I always forget. It's okay for this one?
Yeah, I think your answer, you're repeating his question.
Okay, yeah. So basically Ionic was using a web view, which is why you could run it on Chrome and have a different look and feel obviously than on a native device. But since React Native is not using a web view, it has to be tested on the simulator, which behaves just like a normal iPhone. Some differences apart, including the fact that you can't test push notifications on a simulator. But then I could just have easily plugged in my device on my computer and have the app live reload on my device. If I want to test those kind of features like calling, push notification, texting, all these stuff could be tested. But the simulator does replicate quite well exactly what an actual device does. It provides me with a list of different devices if I want to try different size screen sizes. And for Android, you have also something called Genymotion, which does a bit the same thing. You can install a lot of different devices and emulate on them, so you can do the same stuff.
Any more questions?
Yeah, so thank you very much, Woody.